So hello everybody again. This time we're doing lesson 5.6 about magnetic force. We are going to see that forces act over a distance between magnets and between a magnet and a magnetic material. Note that magnets can have different magnetic strengths. Plan a fair test and identify the independent, dependent, and control variables. Take accurate measurements. Decide when to repeat measurements to get more reliable data. Record results in a table. Present and interpret results on a bar graph. Make a conclusion from results. Getting started. What is the difference between a magnet and a magnetic material? Complete these sentences for your answer. A magnet is a material that has one area around it where something is active. In this area, a magnet can attract or and it can attract a material. The magnetic material does have an area around it where magnetic force is active. So magnetic material cannot another magnetic material. Forces between magnets. Aaron is holding two magnets so that they can swing freely. If the unlike poles are facing one another, the magnets are attracted to each other. This shows the magnetic force of attraction between them. Aaron finds that the magnets are attracted to each other when they are still a distance apart. This shows that the force between magnets can act over a distance. Remember that a magnet is a material that has an area around it where magnetic force is active. So, as long as Aaron holds a second magnet inside this area, the two magnets will be attracted to one another. The stronger the magnets, the bigger the area and the bigger the distance can be. Strength of magnets. Magnets can be extremely strong. Look at the maglev train in the photograph at the start of this topic. So that's a maglev train. This high-speed train uses magnets to work. Scientists have used their knowledge of magnets to invent tracks that are made of very strong magnets. The train floats above the track. We will work with much weaker magnets in class. Let's investigate how far apart a magnet and a magnetic material can be for the magnetic material to be attracted to the magnet. We are going to compare different poles of two magnets to see if some magnets or poles of magnets are stronger than others. Think like a scientist. Test the strength of magnets. You will need two different magnets, such as a bar magnet and a horseshoe magnet, a metal paperclip with no plastic coating, a 30 centimeters long plastic or wooden ruler. Draw a table to record your results in. Magnets. Distance in millimeters. First reading. Distance in millimeter. Second reading. Distance in millimeter. Third reading. Average are the mean reading. And the four poles of the two magnets are magnet 1, North Pole, magnet 1, South Pole, magnet 2, North Pole, magnet 2, South Pole. Your ruler remains in the same position during the activity. Place the paperclip at the zero end of your ruler. The position of the paperclip is dependent on changes of the magnet. We are going to measure these changes. Place the North Pole of magnet 1 at the other end of your ruler. You are going to change the magnet during the activity. Slowly move the magnet towards the paperclip. Stop the magnet as soon as the paperclip is attracted to and touches the magnet. Read off the distance in millimeters on the ruler. Record the distance on your table. This is the first reading. Repeat to find a second and third reading for the north pole of magnet 1. Carry out the activity again with the south pole of magnet 1. Fill in the table. Repeat the activity to test the strength of your other magnet. Calculate the mean readings and fill in the mean reading column of the table. To calculate the mean reading, add together the 3 readings and divide the sum by 3. For example, if your 3 readings were 3.2 millimeters, 3.4 millimeters, and 3.0 millimeters, the sum is 9.6 millimeters, and the mean reading is 9.6 millimeters divided by 3, or 3.2 millimeters. Draw a bar graph to present your results. Use the mean readings. Use a scale of 1 centimeter represents 5 millimeters. Draw a bar for each pole of each magnet. Give your graph a suitable heading. Questions. Why can't you use a steel ruler for this activity? Why did you use a steel paperclip? How did this activity show that forces between a magnet and a magnetic material act over a distance? Were the 3 measurements for each magnet always the same? Why is it good scientific practice to take each measurement more than once? Were the strengths of the north and south poles of each magnet different or the same? What did you do to make sure your test was fair? Identify the control variable and the dependent and independent variables. Why did one of the magnets attract the paperclip from a greater distance away? What do you conclude about whether or not magnets can have different strengths? What type of science inquiry did you practice in this activity? How am I doing? Answer easily, not sure, or no, I am not able to do this yet to the following question. Can I identify the control, dependent, and independent variables in an investigation? Did the group repeat measurements enough to get accurate results? Look what I can do. I can see that forces act over a distance between magnets and between a magnet and a magnetic material. I can see that magnets have different strengths. I can plan and carry out a fair test to find out if magnets have different magnetic strengths and identify the independent, dependent, and control variables. I can record measurements in a table. I can present results on a bar graph. I can make a conclusion from results. So that's the end of lesson 5.6. Thank you and goodbye. See you next time.